So I will have only half of it into 100 would be half kilomole vapor. And what is the composition? My composition now? Much higher than 0.64, let's say 0.63. Okay, anggap ya. So instead of the feed from ZA is 0.4, 100 kilo plus 100 kilogram. Now I have higher A, higher concentration of vapor, 0.63, but only 50 kilomole of vapor. No, I'm not satisfied yet. I want to increase again my composition. I want to have a pure A. So I can do one more time when I cool down my vapor a little bit up to this stage. And then do it one more time. So like this, yeah. So again, you can do again up to here. So this is called a multi-stage equilibrium atau distilasi bertingkat. You got all the blue things here up to maybe 10 stage, and you end up with maybe the yi is around 0.97 or 8, yeah, 0.97 or 8 of A. So it's pure. But the amount, what do you think about the amount? From 200 mixture, maybe you end up with, I don't know, maybe only 3 or 2 kilomole, maybe. Yeah, so you lose another one. You lose a lot of things. So what happened is, now how about the liquid? Because you discharge the liquid. So what happened is from this part, if all the liquid is contacted back into this one into the mixture. Instead of I cool down the temperature, I'm gonna mix it with the liquid. Jadi daripada menurunkan temperatur dengan cara di kipas-kipas atau pakai kondenser, kita pakai entalpinya dari liquid yang lebih rendah, ya. So we add the enthalpy from the liquid, the lower enthalpy. So if we mixture back here, then it can separate into Q phase. Yeah, so it's basically because the liquid will have also a low enthalpy, and this is high. The vapor has high enthalpy. So how if we mix them together and we have the Q phase there? So it's gonna be end up to here again. So it's gonna use. Okay, and this would be the basis of a multi-stage equilibrium. Okay, so we heat it up, the vapor, while the liquid also we contacted the vapor with the liquid. Yeah. So the function of stages or tahap, yeah. The function of stages is first is the contact between the vapor stream from the bottom and the liquid from the top. So when the vapor contact with the liquid, first the temperature of the vapor will cool down a little bit, because it cooled down a little bit with the liquid, so it's gonna form a new equilibrium, a vapor liquid equilibrium. What happened is because there is an equilibrium, so it will release one vapor phase and also one liquid phase. Okay, and then we see another stage here where we got vapor from downstream, and we have liquid there. We contact them together to cool down this vapor in order it would be a two phase again. After equilibrium, the vapor will go into the vapor phase and the liquid will flow downwards. Yeah. So the context calls diffusion process between the vapor and the liquid phase towards equilibrium. And to separate the resulted vapor and the liquid, then because first the resulted vapor and liquid, of course, it has different phase. So the vapor will flowing upwards and the liquid would be flowing downwards. Okay, so and this gonna be the basic for, we call this enriching section or top section or top section of the fractionation column. So we have the feed and we're gonna heat it up using the heat become vapor and also vapor and liquid, yeah. And the vapor will contact with the liquid. The liquid came from the reflux liquid, from the reflux liquid. How we get the reflux liquid is all the vapor, the remaining vapor here. We didn't take all of them, but we're gonna cool it down using a condenser. We call it overhead condenser. So all the liquid here, we're gonna take some as a distillate, and we're gonna put it back as the liquid. We call it reflux liquid or cairan reflux. Yeah. So this gonna be the vapor up there, and this gonna be the liquid there. Okay, so that is the base. So the multi-stage distillation become the basis for the enriching or rectifying section. Up to here, comments or questions?
Ma'am?
Yeah.
I'm so sorry. I don't quite catch why do we need to we need the reflux liquid.
Okay, why you need the reflux? Okay, back from here. Okay. First, why we need the reflux? First, to cool, like I said before, you got it when we have vapor here, right?
Yes.
Yes, and to enrich or to increase the purity of A, I have to cool it down, right?
Yeah.
Yeah, you can cool it down by using fan, kipas-kipas, or using heat exchanger, let's say, yeah, in to cool the temperature. We need to think about the operational one, okay? But however, in here we end up with a small amount of uh, vapor, but we still have the liquids, right? Because we throw up the liquid. Yeah. So the liquid, we're gonna use it as to cool down the vapor. So we use the liquid to cool down the vapor here. For example, so instead of instead of cooling down using heat exchanger, to cool down, I'm gonna use some liquid from the previous stage. Yeah. For example, in this stage, so for example, this is stage 2, yeah. Stage I have vapor that I want to cool it down to stage 2. Instead of using heat exchanger, I'm gonna use liquid from stage 3. Yeah, the liquid stage 3 is came from this stage, vapor and liquid, and then this liquid is actually discharged, harus dibuang kan sebelumnya. Yeah, so instead of discharging it, I'm gonna mix it with the vapor from stage 1. This is has enthalpy, this is has enthalpy. I'm thinking the amount is similar. For example, this is 50 and this is 50, let's say. And then we mix them together, so it become on the here. The idea, it would be looks like that one.
Okay.
Okay, yeah. This is called enriching section, and next week we can start about the stripping section, about this area, how to also to strip the A. We call it stripping section atau pelucutan. How to strip the A, and we end up with the bottom product. Any other question?
Ma'am?
Yeah.
So I just want to make sure what you were referring to as the liquid here is what we call the reflux liquid in the next slide. Is that correct or no?
Yeah. Yeah. The reflux liquid. The reflux is this one. Yeah. This is reflux liquid. Reflux is cairan yang dikembalikan lagi ke dalam kolom distilasi. So it's called reflux. But in the tray here, one tray, you will end up with one liquid coming in from the previous stage, and you end up also getting one vapor from the previous stage as well. Yeah, from this one. So basically later you will learn that in one stage of distillation, let's say this is stage N. Yeah, this is stage 1, 2, 3, etc. This is N plus 1. This is called this is, we call it YN, and the living stage is called XN. This is we call it the fraction of the vapor coming from the down side of the stage, maybe YX plus 1, and this one is X coming in from the previous stage on the top stage, so X and minus 1. Yeah, I'm gonna discuss this in detail in the module 2 about distillation column. All right, any other question? Just ask me. It's a little bit challenging. Usually I should go around the class and then check your understanding or check your drawing. But yeah, we need to do it online. So yeah, so let me know if you have questions. No more questions? I think that should be enough, yeah? Oh, okay, almost 11 o'clock then. All right, I think I would conclude this session. And then thank you all for listening and for all this the background, yeah, tukang and everything. So thank you for listening, and we'll see you on Tuesday, yeah. All right.
Thank you.
Yeah, then.
Thank you,
Thank you,
ma'am.
ma'am.